Okay, welcome back students. So in the previous class we have done the algorithm for linear search. Okay. Now in this class we have to study the program for linear search, and that program is very important also for practical purpose also. Okay. This linear search program is very important, very important. Just you mind it. Okay. Because this program is coming theory exam as well as in practical exam also. Okay. And algorithms I already discussed in the previous class, and okay, if you any doubt you can ask me. So we done a program for linear search. Okay, write a program for linear search in array, and this program is very large, that's why I take some more space. You just write down serially. First one is in header file, but program is very easy. Okay, if you understood the algorithm, program is very easy for you. You easily understood. If you understood the algorithm, then you easily understood. I mean easily you understood the program. Okay. And Conio console input output. After that we have to define a function, declare a function int L search. We take the name of function is L search because this is linear search program. L search we take some parameter int one array int comma int. Okay, this is the function declaration, right? Now we have go inside the main function. This is the main function. Okay. First, this is header file. This is function declaration, and now we go into this main function. Means this is function is declared always outside the main function, and function is called inside the main function. And after that, we have to give the function definition. Okay. You already know this thing. See, we take the variable int AR50. Okay. Again, I say the function name is L search because this is linear search program. And now we go write the main function part. Item one variable item n index. Right. After that, see out one printing statement. Enter desired array size. Okay, and now we give the value of this array size in n, this variable, in n, this variable. Okay, now enter array element. Backslash n, enter array elements, right? For that, okay, here we also take backslash n because element is in a new line. For we take the loop int I is equal 0, I less than n, I plus plus. Okay, for that array index. Okay, and sin we give the value element in that array. Now see out enter element to be searched for. Now this is the concept. You see, enter element to be searched for, right? And where the element search for this in this variable item. In this way, the item means this is the search element. Index where the searching item will be held. L search, this is the function call. AR number of size of array and item. Okay, if index is equal to -1, I show you this the concept. Sorry, given element could not be found. The printing statement will be given element could not be found. Okay, else here you can do backslash n also. Else cout element found and found at index this index variable index and position is equal index plus 1. Okay, okay, 1 second. Position index plus 1 and the line handle. Okay, and last is return 0 and yes see. And now after that we have to give the function definition. One small part will be left. There is no space here. That's why I first of all teach you this. After that I write down. Okay, program is not completed. Okay, one last portion will be left. This is the function definition will be left. Okay, first of all I clear you this concept. You see, we take the function for linear search as the, by name is L search. Okay, this L search. We take one array and we take two int variable. One is for size of the array and second one is for the required item, means required element. What element will need to be searched, right? See, in the main function we take a array of 50, means a large array which has memory size 50. This item which is be searched element take as a variable item. N is the size of the array and index is the what? Index is the items index, means the element index in where the element will be found. Okay, suppose element will be found at the index 4, means the 4 will be stored in this index, means the index stored the position, not actually position is index plus 1. Index is the means in where the element is held, in where the element is already have in the array. Okay, I show you the output also, don't worry. Enter desired array size, and array size is in this variable n semicolon. Enter array element, and array element is under this loop. Suppose this is an array 0, 1, 2, 3, 4, 5, 6 means your size of array is what? 7 means your n is 7 means your index is starting from 0 to less than n means 0 to 6 means less than 7. Understood? And ARI means with the respective elements. Suppose there is in element 11, 12, 13, 14, anything means ARI means the element with respect to the index in the array. Right? I hope you clearly understood up to this. This is very easy. And after that, enter element to be searched for. What element will be searched for? Suppose this is the array element 15, 16, 17. Suppose you have to find the element of 16. That element will be in which variable item, right? And this is the function call. You see, else in array we give this array. This is for size and this is the item. If index is equal to -1 means if the array is not held, array is not existed, means sorry given element could not be found. Array index is equal to -1 means what? This means only this. Okay, means your array is not existed. Okay, means that this concept is what? Index is equal to -1 means your array is suppose not existed. Means your element, how you element found in the array. Suppose array is not existed, now how you find any element in the array? That's how we write here one possible statement. Index is equal to -1 means sorry given element could not be found. Otherwise element found at index, suppose this index, suppose this is the search item. Okay, item is equal 16. Okay, 16 is already in this array means your index is what? 5 and position is what? 1, 2, 3, 4, 5, 6. 5 plus 1, 6. Means your index is 5 and position is index plus 1 means 5 plus 1, 6. Or suppose this element you search for, your index is 6 and position is 7. Got it? Or suppose you search a element outside the array, suppose 11, 12, 13, 14, 15, 16, 17. Suppose you search the item for 18. What I already teach you in the algorithm means 18 is not equal to any element of this array, means search unsuccessful. Means you can say like that this concept is coming in this. Index is equal to -1 means your required element is not inside that array. Not anyone in this, it is not equal to any element in that array. Means you can say this condition is coming in this if condition. Means ultimately if is for unsuccessful and else is for successful. Index and position is different thing. Index and position is index plus 1. Okay? And suppose you search for an item, first one 11. This 11, 12, 13, 14 I take it. Okay, 11, 12, 13, 14 any value, any integer value you can take it. 11, 13, 14 or this 6 we define. Because your maximum array size is 50. Any value you can, suppose you take in any longer integer, longer array for 0, 1, 2, 3, 4, 5, 6 up to 16, 18, any array you can take, any integer value you can give, any value you will be searched for. This is just an example for your understanding purpose. I take it. Okay, don't be confused, right? This is logically, you just thinking logically. Okay, right? And last one portion will be left. I write down. You just serial write down after this. And this example, if you want to write down, then you can write separately in your copy. I just write down for your, I draw the array for your understanding purposes. If you want to write down, then you write separately. Okay, don't mix up with the program. Okay, don't mix up. I just write here for your understanding purposes. Don't mix up. with the program. Inner copy, okay? I just write down this example for your understanding purpose. I can say you. Don't mix up with your program inner copy, okay? If you want to write it for your concept purposes, then you write separately. If you understood the algorithm, then you easily understood this thing. Okay? After that, we have to define function definition. Okay, you see. Int array int size and int item. Okay. Right, this is a C. If item return I means the index, and otherwise return -1 means unsuccessful, right? Return -1 means this index is equal -1, right? Okay. Okay. You see, this function definition is already I discussed you. I already discussed this part. Means array size item, and this is the size. If item is equal to this element, means return I means return the respective element index. Otherwise -1. -1 means this unsuccessful. Okay. Again I say show you. Suppose array is 1 2 3 4 5. Means size is what? 6. That's why 0 to less than size means 6. Suppose I take integer 26, 27, 28, 29, 30, 31. Right? Means suppose your element is 28, which is you search for. Means when you compare with this, not equal, compare with this, not equal, compare with this, means your array 2 will be 28. Means array 2 element 28 and your search item is 28. Means search successful. When the return I means return this index, means your index is 2 and position is 1 2 3, means 2 plus 1 3. This understood? Otherwise, if you suppose if you find the element 32, means if you compare with 26, not means return -1, means search unsuccessful. Because the element is not held in this array. Understood? Means the required search element is not in the array. Okay. Means compare one by one. I hope you understood clearly. If you any doubt, you can ask me. Now we start the binary search topic, the second search topic, and this is also very, very important. Binary search. Suppose in last year one questions problem coming from binary search. Problem, okay? In binary search there is 3 actually we have to study: algorithm, program and problem. Three things. In linear search, we study algorithm and program. But in binary search, we have to study algorithm, program and problem, mathematical problem. This problem is coming in also final exam. Last year, I suppose remember one problem is coming from binary search. Okay. Okay. Binary search. See, I don't give you the definition, the note. This is already in the books. I just tell you. In binary search, you see, why we need binary search? Means you see, if in linear search, suppose there is a very big array, okay, suppose 0 to 49, just you assume it, but 0 to 40, right? Means your element is what? Suppose 0 to 39 means what? 40 element, and you have to compare each, you understood? Means suppose this is an array, okay? Your starting is 0 and ending is 39, means what? 40 element will be in the array, and your search, suppose element is in the 39th index, means 40 number. Suppose your searching item is in 40 position, means 39 index. Suppose you estimate, means you what? You comparing this item with everything, everyone, 0, 1, 2, 3, like go 0, 1, 2, 3, go. You 40 times comparing. 40 times comparing. You just imagine it. Means how many times it will be taken. How many times? So many times it will be taken. Your efficiency will be so many low. You know what I want to say means in linear search what? Suppose there is a very big array and your search item is suppose in the last portion. Means you have to be searched many times. Means you just see it. I just give you example. Suppose one array is for 0 to 99. Suppose just say 0 to 99. Means 100 element, and your search item is in the 99 position, 99 index. Any item. In the 99 position, 99 index means 100 element, and you search for 900 times, means comparing 0, comparing 1, comparing 2, 3, like that 100 times. You imagine how many time taken, and this problem will be overcome by binary search. That's why we need binary search. Means time efficiency. Binary sciences searches for time efficiency. Means how many comparison we needed in linear search, and in binary search we don't search like this way. In binary search we search through some formula. That is I want to teach and I want to tell you. Okay. This disadvantage of linear search is overcome by binary search. But one condition, means one advantage in every linear search has also advantage, and binary search is also advantage. Means main thing is in binary search the array must be sorted. Means okay, array must be sorted. in binary search. Means in linear search, sorted means you understood. Sorted means in a order, either ascending or descending. Means suppose you already done many in chemistry in ascending descending order, okay? For problem. Or suppose physics also means ascending descending order. I hope you already done many thing about ascending descending order. Okay, ascending descending means in a organized way, right? In a organized way. I hope you done many like that concept in other subject. Okay, I tell you. Suppose this 1, 2, 3, 4, 5, 6 means this is what? This is ascending order and this is descending order, right? Like that in binary search, array must be either ascending or descending. Okay, randomly organized array is not useful for binary search. This is the binary search disadvantage. I clearly show you the advantage disadvantage part of linear and binary search. Just once again. In linear search, we can search in linear search we can search any array, search any item for sorted or unsorted array. Means suppose this is an array, okay? 0, 1, 2, 3, 4, 5, 6. Suppose element is this 11, 9, 8, 17, 6, 21, 37. Means this is unsorted array. You see 11, 9, 8, again 17, 6, 20. Means this is randomly element, not any organized. This is neither ascending nor descending. Means unsorted. But linear searches will be possible in this unsorted array. Okay, but binary search is not possible in that array. Binary search is always for sorted array. Means your array will be like that. 11, 12, 13, 14, 15, either ascending order or either means what? 16, 15, 14, 13, 12, like that, descending order. Okay. Binary search is either ascending or descending. Means binary search always for sorted array. But in linear search, time is not efficient. But in binary search, time efficient. Or you can write like time efficiency. Means both have advantage and disadvantage. Okay. Means in linear search, the array is either sorted or unsorted. But in binary search, it must be sorted array. But in binary search, time will be saved by some formula. I teach you in the next class. But in linear search, time is not efficient because we have to compare with each element. Means you have, suppose for big array, time will be for many more time will be taken for searching in linear search. Okay. So, okay, this will be enough for this session. Okay, in next class we study the binary search algorithm. Okay, in binary search algorithm there is two possible way, either in ascending or descending, lower to upper bound or upper to lower bound. I show you in the next class. Okay, in next class we study the algorithm for binary search. Thank you.